Section 2.4, Properties of Quadratic Functions, Part 1. Recall that in Section 1.5, we learned to graph different functions using transformations. But in this section, the quadratic functions are a little more complicated, and so we need other information about our graph. But before we do that, let's go ahead and review Section 1.5. So if we graph y equals x plus 3 quantity squared minus 1 using transformations, what do we look at? We'll take a look at the plus 3. What does that plus 3 do to our graph? The graph shifts 3 units to the left. And what does the minus 1 do to our graph? Well, the graph shifts 1 unit down. So we're going to go ahead and shift our parabola. So our parabola initially has a point at 0, 0. We're actually going to take that point 0, 0, and we're going to move 3 units left. So now we are at -3 and 1 unit down. So we are now at -3, -1. Okay? And we also know that our parabolas are symmetric. So it's going to look exactly the same on both sides because it's symmetrical in respects to the y-axis. And that is what our function looks like using transformations. I didn't go too much into detail because we spent a whole section going over how to graph those using transformations. Now in this section, we will use 3 properties of quadratic functions to graph because they're a little more complicated. The first one we're going to use are x and y intercepts. The second thing we're going to look at is the vertex of our parabola. And then finally, the axes of symmetry. And let's talk about what those actually are. So let's look at this one first. Okay, so what goes in that blank? Do you know? So we are looking at where the graph crosses the x-axis. So those points there, what does that look like? That looks like maybe 0.30, and the 0.40 are our x-intercepts. Okay. And then now I'm looking at this other point over here, the 0.01. What is that called? If you said the y-intercept, then you are correct. Okay. And then we have this other point, and I'm looking at the one I just highlighted. We have that other point, which is the lowest point on our parabola. What is that called? That's called the vertex. Okay. And just so you know, if our parabola was flipped and it looked like this, then the highest point would be our vertex. So notice that the maximum and the minimum are always where your vertex is. And we'll get back to that because we are going to talk about maximums and minimums. Okay, there's one last thing that we have not talked about yet, and that's this line here in the middle, the one I just highlighted. So if you look at that line, the one that is dotted and highlighted, the parabola looks exactly the same on both sides of this line. It's a mirror image, and that's called the axes of symmetry. Go ahead and write this down. So that line is the axis of symmetry. So when they're asking for axis of symmetry, remember that it's not a point, it's a line. So in this case, for example, in this case, our vertex is, I think that looks like -3 maybe. So our vertex is 2, -3. So our axis of symmetry is a line. So it should be the equation of a line. So our axis of symmetry would be x equals 2. And I will continue in the next video. So stay tuned.